Hello and welcome back. In previous lecture, we discussed the relationship between force, pressure, flow, and speed for a closed vessel, and what mechanism will lead to raise or lower a piston with a rod. In this lecture, number 6, we'll start talking about hydraulic and pneumatic systems. What are their common components and methods of operations? So, these are simple schematic for a typical hydraulic and pneumatic systems, and we'll come into details of each components during coming lectures for hydraulic system. At this moment, let's identify in brief the basic components of both systems. In hydraulic system, at the left hand side, we have an oil storage tank, or sometimes we are calling it a reservoir, then a filter used to clean the oil, a motor-driven pump used to supply constant volume with pre-calculated pressure, a pressure regulations to control the pressure of the hydraulic fluid, then piping which act as a closed loop to carry the fluid or convey the fluid, and then a control valve with multi-positions and ports to supply the fluid to a cylinder with a piston rod. On the other side, for the pneumatic systems, we have normal air introduced to a filter for cleaning, then a motor-driven compressor, air cooler and air treatment unit, storage reservoir with pressure switch. And if you remember our previous lectures, we told that the gases normally are compressibles, hence it need to be stored for pneumatic system. And after that, another control valves with multi-positions and ports used to supply air to a cylinder with piston rods. Those are the basic components you can find in any of hydraulic or pneumatic systems. Let's start with hydraulic system, and as a definition, it is a mechanism activated, controlled, or powered by liquid pressure, while concerns on the study of liquids at the rest and in motions, especially under pressure. In the meantime, the application of this particular knowledge has a big contribution in the design and the control of the system. If we want to describe the system in details, this consists of a movable piston connected directly to output shaft. And here, if you can see, we have here this cylinder with a piston and shaft responsible for lowering or producing the action or motion. Then just imagine the fluid introduced from the tanks going to a port A. So if the fluid is pumped into a pipe A, the piston will move up. If the fluid is pumped to the port B or the pipe B, then the piston will move down. Obviously, some method of retrieving fluid from non-pressurized side of a piston must be incorporated. Sometimes we are facing lots of excess fluid. This need to be returned back to the tank. The maximum force available for a cylinder, to obtain a maximum force from this cylinder, it depends on the fluid pressure which is supplied and the cross-sectional area of that piston. So just remember, as we discussed earlier, the force is determined by pressure. This system requires a liquid fluid to operate, and this liquid up to a certain extent is expensive and messy, and consequently the piping must act as a closed loop. We'll list down the steps of the system operation. It first starts with the fluid is drawn from the tank by a motor-driven pump, which produce fluid flow at the required pressure. This fluid then will pass through a filter for cleaning. Then it goes through the pump, which produces a constant volume of fluid with a predetermined pressure from input to output ports for each revolution of the pump shaft. And such high pressure pump, however, cannot operate into a dead end load, because in case of dead end load, the fluid pressure will rise indefinitely until the pipe or the pump itself will fail and the system will collapse. So some of pressure regulation, as shown here, is required to spill excess fluid back into the tank. Cylinder movement is controlled by three position changeover valves. To extend the cylinder, port A is connected to the pressure line and port B to the tank line. To reverse the motion, port B then will be connected to the pressure line and port A to the tank line. In each center position, the valve locks the fluid into the cylinder, thereby holding in a position, and the dead ends the fluids lines, causing all the pump output fluid to return back to the tank via pressure regulator. Now, just we need to take some few auxiliary points. First, the speed control is easily achieved by regulating the volume flow rate to the cylinder. In order to control the speed of this movement, whether up or down, it is controlled by achieving or regulating the volume flow rate to the cylinders, and this mainly being done by the control valve. Precise control at low speed is one of the main advantages of hydraulic systems compared to the pneumatic system. The second point, the travel limits are determined by the cylinder stroke, and cylinders generally can be allowed to stall at the end of the travel, so no over travel protection is required. This is again another advantage in hydraulic system. The third point is that the pump needs to be turned by an external power source, almost like an AC induction motor, which in turn requires a motor starters and overload protection, like any motors, AC motors we are using in industry. The fourth point, that the hydraulic fluids need to be very clean, and hence filter is required to remove all dirt particles before the fluid passes from the tank to the pump. If the fluid introduced to a pump with some contaminations, it may destroy the pump. And one final point worth mentioning, that the leaks of the fluid from the system are unsightly, slippery, and hence hazardous. If a leak of a hydraulic oil, it may cause some of the safety concerns and environmentally undesirable. And major failure can lead to a catastrophic. So, as a part of this course, in the section number 4, we'll be having some discussion on safety and hazards from a hydraulic system. Thank you, and see you next lecture.